Atlas is the culmination of over a decade of hydraulic humanoid robotics work at Boston Dynamics. Atlas stands about 5 feet tall, weighs about 190 pounds. It's battery powered and hydraulically actuated with 28 degrees of freedom. It has RGB cameras and depth sensors, which provide input to its control system, and all of the computation required for control, perception, and estimation happens on board its 3 computers.
At a practical level, it's a platform for us to do R&D on. And as an Atlas team, we're encouraged to push that platform to its limits, like do the most crazy, exciting, high-power stuff we can do with it. And so we're always expanding and pushing the limits of Atlas's capabilities, and then hopefully by extension, extending the capabilities of the company as well at the same time.
Parkour is a useful organizing activity for our team because it highlights several challenges that we believe to be important. First, how do we build a high power density mobile robot that's capable of extended athletic behavior? How do we design control algorithms that can create a variety of behaviors and control them robustly? And how do we connect perception to action in a way that both captures long-term goals like getting from point A to point B and short-term dynamic goals like adjusting footsteps and applying corrective forces to maintain balance?
What makes Parkour Mountain hard was not so much the individual moves, those had been worked on a lot prior to kind of pulling together, but running the entire course, doing it in one contiguous set of operations really drives the need for reliability and repeatability. And these are things that are pragmatic, but really difficult. And that's what the team really focused on. I think the biggest success is being able to show all of those exciting things pulled together and done repeatably and reliably.
It can be frustrating sometimes. The robots crash a lot. It's not the robot just magically deciding to do parkour. It's kind of a choreographed routine, much like a skateboard video or a parkour video where it's an athlete that's practiced these moves dozens or hundreds of times even to get to that that high level, that exciting capability. So we're kind of doing the same thing here with Atlas. We're exploring how to push it to its limits, sometimes operating at those limits. And we learn a lot from that in terms of how to build robots that can survive falling on their face and getting back up and doing it again. We also learn a lot about the behavior, the control, the thing that puts one foot in front of the other.
These videos are a true team effort. First, of course, we have the software team who is responsible for creating all the behaviors and control software required to execute the behaviors reliably on the robot. We have a hardware team who's responsible for making strategic upgrades to our robots that enable things like extended dance and parkour routines. Our technicians debug and repair a variety of issues that can range from broken mechanical parts to hydraulic leakages to electrical failures. And our operations staff is responsible for building these environments and repairing them when robots crash through them and helping us run the many, many tests required to get this kind of a demonstration to a high degree of reliability.
Yeah, that's broken. Hey Tom, you wanna grab me a flathead?
Yep.
Gotta do it.
Our job is to get him back out on the floor and working again. Sometimes it looks disastrous and we're like, oh, we've seen this before and we can fix it so easily. And then sometimes we end up with something that looks benign and it will take days to get down to a root cause and figure it out and then repair it. It's a balancing act between getting down to root causes, improving designs, and keeping the robots running around out on the floor. Okay, nothing looks out of the ordinary, right? Everything's out of the way. Okay.
The most rewarding thing about my job is that I never have to work very hard to explain why I love it. I love working on robots. I love working with people that have passion to push, to try new things, and really just explore things that have been unexplored. And I think almost every day at Boston Dynamics involves elements of that.
The work that we're doing now, I view as really just foundation building. We're building the core capabilities that we think any useful robot will need. And in doing so, we're really defining the next set of challenges that we're going to be working on over the next 2 to 5 years.
It's extremely hard, but it's also very rewarding. You know, it's like, I wouldn't want to be somewhere where I'm not working on like a super hard problem that nobody else is working on. So, you know, it's just, that's the opportunity that we get to do here every day.
3, 2, 1.